Okay, there we go again. Let's just bring up the drive a little bit, bring up the drive and just peak it for power. 75-80 watts. That's just over 100 watts there. Okay, at 250 milliamps. 250 milliamps cathode current, so we can clearly get the power up from 29.7. Well, that's not the whole story. Let's also have a look at the two-tone performance here. So I'm going to just adjust the analyzer here a little bit first of all, to bring the signal to the top of the screen, make it easier to see what's going on. Okay. So the span on the analyzer is now 10 kilohertz. Well, what we'll do, we'll start off with just calibrating things to make sure they're right before we do a two-tone test. So what I want to do is to make sure that the wattmeter is reading about 100 watts. This is on a frequency of 28.7 megahertz. And I also want to look on the scope such that I know what voltage peak to peak on the scope corresponds to the 100 watts. That'll become apparent in a minute why that's important. So we're just going to key this radio on again. 100 watts output, but I don't want to keep it there for any longer than what's necessary, so I've got to do this pretty quick. And that is 100 watts carrier there, peak to peak. There's a lot of glare, so you can't really see it on the screen, so I'll just try that again. That's 100 watts peak to peak. So that's all but one division top and bottom on the scope for 100 watts. Okay. So now what we'll do, we'll go to two tones. Upper sideband two-tone test. Which is not quite so brutal on the PA. And we'll key it up again. We'll just adjust the mic grain, so we're just getting just a nice envelope pattern there. Nice two-tone test. Perhaps see that a little bit clearer with that light off. And that's equivalent to about 100 watts PEP. Thereabouts. So that's to flatten off there at the top. Back off, so it's not quite flattening off. It's about as good as it gets. We'll pan across to here. Turn on the lights. And on the two-tone testing, we can see that we've got about 30 dB IMD. I'll just adjust the amplitude here. Peak search, marker 2, peak search, marker 2, reference level. So the IMDs are about 28 dB down or so, not quite within spec, should be 31, but that is a sort of genuine 100 watts PEP output. Of course the wattmeter only shows about 40, because that's only measuring average power, not even that. I'll just turn it up so it's a little bit higher, but I know I'm going to go into compression if I do. About 40, yeah, still not flat topping on the scope there, still looks pretty reasonable. And the IMDs are, I'll get zoomed in here, about 30 dB down, so actually not too bad all told. Okay, let's stay that. Turn that off there. That's it. Power's gone now. That's it, off. Incidentally, what we can do here, while we know the top of the screen is maximum power, if we just key up the radio with no tones going in, just as an aside, you can see there's some noise there. Well, what we're actually looking at there, that's the suppressed carrier peak. was, I just nudged the dial there, there's just a smidges. And you can still see the actual carrier is 40 odd dB down, and hum and noise is 60-70 dB down. So that's the actual SSB bandwidth across there. Bear in mind this is 10 kHz per division, so we're about 3Ks, about 3 kHz bandwidth, and you can see that the carrier is quite nicely suppressed there, and there's no excessive hum or noise coming through. So that all looks good. So 28 megahertz, we can get 100 watts output, IMD, round about minus 30 dBc, thereabouts, give or take, which is pretty good, and that's on a frequency of 28.7 with a two-tone test of 800 Hz and 1.8 kHz. I'll just stop the camera here for a second.